Welcome back to classroom. So right away we'll be talking about balancing of chemical equations. Our chemical equations are representation of chemical reactions, yes. And we have different type of chemical reaction. We have the neutralization reaction, precipitation, decomposition, displacement reaction, even combination reaction. So, and we have to balance such reactions. And one thing about balancing of reactions is that whatever you have on the left hand side must be equal to whatever you have on the right hand side, and that is where your atom count come into place. So I'm going to be showing us. Then another thing is this: there is a prototype that you can use for your displacement reaction, whereby you have maybe AB plus CD. So you have something like this, AD plus CD. So for, especially when you have binary compounds, so it can come into play like this. So I'll be starting with the combination reaction. Yes. Okay, let me just do something under the displacement reaction before we move. For example, maybe you are, I think the precipitation reaction, yes. If you have something like this, your HCl plus what? Plus your silver nitrate to give me what? This, we just go like this. So HNO3 plus what? The silver chloride, yes. So, and both the right hand side and the left hand side, they are balanced. I have just one hydrogen here, one hydrogen, Cl, silver night, my silver, just one atom, everything is balanced. Okay, then there's another one that we'll call the combination reaction, whereby you have two elements coming together to form a compound. So for instance, maybe you have your hydrogen plus oxygen to form what? Water, H2O. Okay, you have it to form H2O. So I'll have to balance it. Oxygen is 2 here. Okay, if I put 2 here, now any number you put behind affects everything in front. So my oxygen becomes 2 already. Then my hydrogen will be 2 times 2, 4. So I have to put another 2 here. A very beautiful example again is your chlorine plus hydrogen gas to give what? HCl. So I have 2 atoms of each of them. So if I put 2 here, it balances for the 2 of them. Okay, so we can also have what we call the decomposition reaction, whereby you have a particular compound breaking into other compounds. A very beautiful example is your calcium carbonate as well. So my calcium carbonate is going to break into calcium oxide and my carbon 4 oxide. So my calcium here is 1, oxygen is 1, then my O3, my oxygen is 2 here, 2 plus 1 will give me 3, so that balances it. Another beautiful one is my potassium chlorate. You have KClO3, yes. So I have it to be breaking into KCl, that's my potassium chloride, plus my hydrogen gas, but is not yet balanced. Yes, it's not yet balanced. So I have 3 for the oxygen here, and I have 2. So I have to do a multiple. What can I multiply with 3? That will give me the same thing when I multiply with 2. So I will do 3 times 2 will give me 6. And 2 times 3 will give me 6. So I'm going to put 3 here, and I'll put 2 here. So, and this 2 affects everything in front. So I'm going to put another 2 here. So my oxygen here is 2 times 3 is 6. 3 times 2 is also 6. And every other thing here is 2. And it's 2 here. So it's balanced as well. So I'll be going to neutralization reaction, whereby you have your acid NaOH reacting with my HCl. Okay, to give you can also use this method as well, like this. I usually tell students, whenever you cite hydrogen and you cite OH, know that H2O will be formed. Yes. And whenever you cite maybe hydrogen is somewhere and CO3 is somewhere, know that water and CO2 will be formed. Yes. So just have that at the back of your mind. So I have NaCl, that's my sodium chloride, plus what? H2O. So that balances that. Okay, another beautiful example. Okay, we can have Na2CO3 plus HCl. It's still a neutralization reaction. So you have something like this. I want to show us how the water and the CO2 will be formed. So my NaCl will be formed plus what? Plus H2O plus what? And I told us when you are looking at hydrogen and CO3, water and CO2 will be formed. Yes, CO2 will be liberated. So we'll now find a means to actually balance the reaction. Hydrogen is 2 there, so I'll put 2 here. My sodium is 2 here, so if I put 2 here. Okay, so with the look of things, I guess it's balanced. So let's do our atom count and see if it's actually balanced. I have sodium to be 2 here, is 2 here. Carbon is 1 here, is 1 there. Oxygen is 3 here, 1, 2, 3. 1 plus 2 gives me 3. Okay, my hydrogen is 2, hydrogen is 2, chlorine is 2, so it's balanced. Okay, so another one that I would like us to do is a combustion reaction whereby you have oxygen reacting with an organic